All right, so this is 5.5 homework questions here. I guess I should put that kind of at the top so we know what we're dealing with. And so let's start with the lowest number here. Let's do 20. No, we'll do 5.4 in a second. We'll start with 5.5. Let's do 55. So looking at 55 here, we have solve by completing the square. And let's get a slightly larger picture.
Mic check.
Is it working or not good? Maybe he's checking for himself. All right. So looking at this one here, the first thing I want to do is I want to say, okay, to solve this equation, I'm going to be completing my square. I want this thing to basically have a value of 1 inside of what I'm going to be completing my square for. So when I look at this, if I wanted to, could I divide this entire equation by 2? Yeah, I absolutely can, right? So I can take this thing, divide it by 2, whoopsie, and I get x squared minus 6x, I'm going to leave a space, equals -7. I don't care about this -7 over here. If you want to bring it over and like deal with it as the c value over here, you can, or if you just want to leave it on Lonely Island, that's fine as well. It really doesn't matter. My next step here is going to be to look at my equation and look at my b value. My b value here is -6. So in terms of what I want to do to complete my square, to find what I want to put here, I'm going to take my b value, divide it by 2, and I'm going to square that thing. So here I have -6 over 2, and that's being squared, which is -3 squared, which is 9. So the thing that I wanted was 9, so I'm going to just add 9 here. But I do have to keep the universe balanced, so I'm going to subtract 9 as well. Again, if you wanted to add 9 to both sides, you can. I typically just do this because I see people make fewer mistakes this way. You do you. The next thing is I want to say, okay, well, what is it that I really wanted? I really wanted to take these 3 things and to turn it into a binomial squared. So this is my perfect squared trinomial that I just created, and I want to turn that into a binomial squared. So this thing is going to end up looking like x minus 3 squared. So again, this factors into this. -9 still just hanging out. And now my next step is going to be to get rid of all those things. So here I'm going to add 9 to both sides. Here I get x minus 3 squared equals 2. And now I'm going to take the square root of both sides. So square root, square root. As soon as I take the square root, I'm going to get plus or minus. So x minus 3 equals plus or minus the square root of 2. My last step will just be to add 3 to both sides of my equation here. And my final answer is x equals 3 plus or minus the square root of 2. Any questions on that one? Cool. All right. Let's take a look at 71 here. All right, so for 71, I'm basically in the same boat, and this time I see a bunch of decimals. I hate decimals, I don't want to deal with them. How do I get rid of it? Well, the first thing I can do is I can say, well, to get rid of decimals, I could just multiply by like 10 or 100 or 1,000 or however many I need to bump it. So I'm going to multiply this entire thing by 100. Now you can absolutely solve this equation without doing that, but I prefer to do that just because we have it set equal to 0, so why not? So here now this becomes just p squared minus 22p plus 290 equals 0. Well, cool. Well, the next thing I'm going to do is I'm going to say, well, is this 290 what I wanted? No, it's not what I wanted. I wanted whatever 1/2 the square root of that thing, or excuse me, yeah, 1/2 that thing squared is going to be. So here again, my b value, negative 22, divided by 2 squared. So this ends up giving me negative 11 squared, which is 121. So the thing that I wanted this to be was p minus, oopsie, p squared minus 22p plus 121, the thing that we just found over here. And then to keep everything balanced, I subtract 121, and I've still got this plus 290 hanging out on the outside. This is my perfect trinomial square. So now, or perfect square trinomial. And so now I'm going to factor this. It factors into p minus 11 squared. Now on the outside here, I've still got my 290 and then minus 121 ends up giving me 169. And that whole thing is still set equal to 0 because 100 times 0 is just 0. And so now what I'm going to do is I'm going to subtract 169 from both sides. And I get p minus 11 squared equals negative 169. Now again, if you don't have like all your square tables memorized, that's okay. You can use a calculator for this, but 169 is just 13 squared. So when I take the square root here, I'm going to take the square root here. I'm taking the square root of a negative. What's going to come out is an I. Okay, so again, always going to be plus or minus. And now the square root of 169 is 13, but it was a negative, so it's just going to be 13i. And I have p minus 11 is plus or minus 13i. I'm going to add 11 to both sides. So my final answer here should be p equals 11 plus or minus 13i. Any questions here? Perfect. All right. Let's look at the next one. Oh, wait, hold on. Let's do this. So zoom, Control H. No. Zoom, your shortcut keys don't even work. You have bad UI, Zoom. Can we do 87? Let's look at 87 here. So this would require us to have a little bit of knowledge of trapezoids, which hopefully we remember from geometry. So the area of a trapezoid is the first thing we want to start out with. Area of a trapezoid is equal to 1/2 the height times base 1 plus base 2. So now when I look at this thing, I'm told what the h value is. The h value is x plus 4. And I'm told what my base 1 is, which is x. And I'm told what my base 2 is, which is 3x. And you swap those things, it really doesn't matter. I'm also told the area in this problem is going to be 70. So that's my area for this thing. So I'm going to start writing my equation as 70 equals 1/2 times x. Oops, sorry, that should be x plus 4. Times my x1 plus. And so now I'm going to do a little bit of simplifying here. I don't know, what do we want to do? Purple's left. So 70 equals 1/2 of x plus 4 times 4x. Now, there's a lot of things you can do with this 1/2. If you wanted to multiply both sides of the equation by, oopsie, that should be squared. That should not, oh, no, this is not. Just kidding. Yeah, these are added together. Then we're multiplying, so we'll have a square value of x after, but this is just 4x. So when we're dealing with this 1/2, again, I personally would just do 1/2 times 4, and I'm going to have this turn into a 2x. If you want to multiply both sides of the equation by 2, and this be 140, and then this disappear, that's fine as well. It really doesn't matter. So I'm going to take this 1/2 and multiply it by this 4, because really this is just chunk times chunk times chunk times chunk. So when we're doing this, this turns into x plus 4 times 2x equals 70. So now from here, since it was 5.5 stuff, it probably wants to solve by completing the square, so we can do that. This ends up turning into 2x squared, because I'm doing 2x times x, and then I'm going to do 2x times 4, and that 2x times 4 gives me 8x. And now from here, again, still equal to 70. I'm going to subtract my 70 over. So I get 0 equals 2x squared, oops, minus 70, plus 8x minus 70. And now I look at this equation, I'm like, okay, well, I could just do it like this, or I could divide the whole thing by 2, make my life easier. So now this ends up being x squared plus 4x minus 35 equals 0. Again, you didn't really need to subtract the 70 over. I just do this as like a step-by-step for people to follow, and this is kind of the flow that I use, but again, you don't need to do that. You could have left it over there. And now I'm going to say, okay, well, what is my b value? My b value here is 4. So 4 divided by 2 squared ends up giving me 4, because 4 divided by 2 is 2. 2 squared gives me 4. So now I want that to be x squared plus 4x, and now I would like it to be plus 4, keep it balanced with a negative 4, and now here we got our minus 35 equals 0. My next step is then to take this little bit here and turn it from a perfect square trinomial into my binomial squared. This will just turn into x plus 2 squared minus 39 is equal to 0. My next step here is going to be to take my 39 and add it over. So again, if you wanted to leave the 35 over there and then you'd just be adding 4 over, it's the same either way. Really doesn't matter one way or the other. So here we got x plus 2 squared equals, so add 39, add 39. My next move here is going to be to divide, or excuse me, to take the square root. So I'm going to take the square root of both sides of my equation. So I get x plus 2 equals always plus or minus the square root of 39. So the square root of 39 is like roughly 6 something, because it's bigger than 36 but less than 49. But we're only going to end up really taking one of these things because I can't have a negative side length. So now my final x value in terms of what it would look like strictly from a theoretical perspective, whoops, would be this. But we know now, since this is a, ooh, we haven't gotten pink yet. Since this is a trapezoid, I can't have side lengths that are negative. I can't be doing -2 minus, roughly 6 and get some -8 thing. So I'm only going to be using the plus. So my final answer here should look like -2 plus square root 39. That's what I'd be looking for. Any questions here? Perfect. All right. So I believe, oopsie. Check the chat. That was everything from 5.5. Any other questions from 5.5 before I move to 5.4? Perfect. All right. So I'm going to stop this recording and hope that it doesn't erase the other one. Fingers crossed, everybody.